Hello.
Hello, everyone.
Hello and welcome to this ParaView First Step webinar.
Just one last checking on the time that everyone is connecting.
I hope you can hear as well. Just let us know in the chat if that's not the case. Okay, so let's get started.
So here we are today about ParaView. So there is Matthew and me, Charles. Matthew, I will let you present yourself.
Sure. So I'm Matthew Westphal. I'm a ParaView expert engineer at Kitware for 7 years now. I will be very happy to present you ParaView today. I'll give you some little tips and tricks for your first usage of ParaView. So yeah.
And myself, my name is Charles. I have been at Kitware for 6 years. I mostly work on VTK. So on this tutorial, I will be discovering ParaView with you, with Matthew. And maybe we can have a few words about Kitware first.
Sure. Kitware, our company in the developer of basically ParaView and VTK, are a leader in scientific open source solutions. We develop many open source software. We have more like 200 employees worldwide, and Kitware exists has been existing for more than 20 years now, and we are in constant growth. So yeah, it's a great place to work at, to be honest.
And we hire.
Yeah. So yeah, we're working mostly with open source software, and we create open source software. So that will be of great value, especially as we will see with ParaView. So yeah.
Okay, so maybe we can have a first glance at ParaView. First, can you describe what is ParaView?
So basically, ParaView is an application and an architecture for display and analysis of massive scientific dataset. What we mean by that is that's an application, so you can just run it on your desktop. You just double click on the executable, and poof, it opens on your desktop, and you just open your files. Try to start using some filters to post-process your files, and then save the result as a screenshot or other data. So that basically is the side of ParaView we will see today. But ParaView is much more than that, because it's also an architecture, or we can call it a framework, where you can build your own application, either your own Qt-based application or even a web application based on ParaView. So as we said, that's for display, but also analysis. And we say it's for massive scientific dataset because it scales. It's in the name, basically, ParaView. ParaView stands for parallel, basically. So you can use ParaView on massive scale on HPC, on grid computer. Of course, we'll not cover that today, but that's it.
Okay, and as a user, how can I get it? Should I pay for it?
No, ParaView is completely free, and it's open source. So that means that ParaView can be used and integrated into your own your own commercial software. Because it's BSD license, you only need to keep you only need to mention the copyright of Kitware on the ParaView source code. But other than that, that's the only thing you need, and you can use it for free.
Okay, and as a user, how can I get ParaView?
Well, that's very easy. You just go to paraview.org/download. You can just look for ParaView on Google, and then you go to this download page. You can just scroll. You can find the download link here, and you can just scroll right here, and you will find different versions. Usually, you want to go for the last release. You don't need to go to nightly. Just go to the last release, and then you can choose Windows, Linux, or macOS. By default, it will be on your own system. And just click on the first link, to be honest. If you're on Windows, it can be a bit more complex. Just download the first link is the safest way to go. Maybe sometimes you have different needs and everything, but the first link is, well, that's the safest way to go.
Okay, and once I have downloaded ParaView, how can I launch it?
Well, just double click on it, and it will pop up on your screen. Then, well, that's how it looks when you first start it up. Well, when you first start it up, you have some example visualization you can take a look into. We will skip that today, but once you've done that, that's what you see. Yeah.
It seems there is quite a lot of buttons. Where should I start here?
Well, basically, what you have here is very simple. On top of it, you have all the default menu. You can find all actions into the menus. Then you have many toolbars. All these toolbars are only shortcuts to what you can find in the menu or in other parts of ParaView. This is always like an easy way or a fast way to find an action. Then you have on the left side you have this properties panel thing, and then in the middle you have the main view where you will be able to view things.
Can we try to have some data? I don't know, creating some data in this view just to show it?
Sure. So let's say for now we just create some artificial data, right? Synthetic data. So we'll go with a sphere, right?
Mm-hmm.
That's so I go to source alphabetical, and then I will just press on sphere. So it will create a sphere, a synthetic sphere. So now I see I have an item in my pipeline browser. So that represents that this sphere doesn't appear yet. And I can see here in the properties panel, I have this apply button, which is green. That means that you need, when you see the green apply button, nothing has been done yet, and you need to press it to have something happen. So let's press it. We press it, and now we have our sphere that appears here.
Okay, and if instead of the sphere, I want to open my own data, how can I do that?
Basically, you can you need to go to File Open. So there is this button here, File Open. When you go to File Open, you will that's just a file dialog that that will show you what you have on your disk. So for starter, let's start with a surfacing dataset, right?
Mm-hmm.
So let's open this one. Okay, so now we have, as you can see, I interact with the scene with my mouse.
Mm-hmm.
Okay, so now I have this surfacing dataset here, and I also have the sphere. So I will just choose the visibility of the different object using the eyes in the pipeline browser. When I click on the eye on the sphere here, it just hide the sphere, or show the sphere, and when I click on the eye on the moto, it hide the moto and show the moto.
Okay, and I see that you can also select.
Yeah, and this is very important concept. This is a concept of active source in ParaView. When you select it, as you can see, the properties panel is changing around, and that means that the active object on which I will modify the properties is different.
Okay, I see. And so you showed us that with the mouse you were able to move around the data. Can you just tell us a word or two about how can I interact with the data scene?
So by default, when you left click, it will just, when you left click and you move, it will move the camera around like that.
Mm-hmm.
If you middle click, it will pan around like this in the plane you're seeing right now. And if you right click, it will zoom and unzoom. You can also use the middle mouse to zoom in and zoom. All of that is configurable, of course, but let's not get into that for now.
Okay. So we have seen some surface. Can we have a look at some other kind of data, maybe volumetric data?
Sure. So you may remark that this is the open flow motorbike, right? So let's open the volumic data set associated to this surface. So I just go to File, Open, and I open my volume like that. Okay, so now we have a big volume. We can't really see anything now, so we will need to do some stuff.
Okay, maybe we can try to change a bit the opacity here so we can still see the motorbike inside.
Good point. When you visualize multiple objects, you may want to play with opacity to be able to see through things. So the opacity is on the properties panel. So there is many things on the properties panel. We will not cover everything, but if you just scroll a little bit, you will find the opacity here. And if you just reduce it like that, it's much more clear what we have here.
Okay. And let's say that as a scientist now, I want to do some post-processing.
Yeah.
Maybe, I don't know, create some slice or cut through the data.
Mm-hmm.
How can I do that?
So first, maybe let's focus on what's important here, because the top part of the volume is not that important. So let's clip the top part because we don't want it. So to do that, I make sure that my volume is the currently active source, because I will want to clip the volume, right? Not the motor. So I want to clip the volume. I select it, and then I will press the clip button here. So in in this toolbar here, we have many, we call that common filters. And so we will we start using the clip first. So I press the clip button. As I can see how my clip will be processed. So I will just clip, I will just clip in the Z-axis to have only the lower part. So I press on the Z normal button. That will just change the axis of the clip, and then I press apply. Of course, you can move around, you can change all the parameters of the clips if you want, but right now this is fine for me. So I press apply, computed, and now I will uncheck the show plane because I don't want to see the plane widget anymore. And as we can see, it's a bit confusing because we have the previous object which is still seeing and the new object which is opaque. So I will hide the previous object and add some opacity again on my clip. That's it. Like that.
Thanks. And can we also have a slice, for example, on the clip or on the original datasets? How can we do
Sure.
this kind of processing?
So right now I have my volume and my clip. Only the clip is visible. Let's say I want to slice on the clip, not on the original volume. So I will make sure the clip is selected in the pipeline browser, and then I will press the slice button. As you can see, there is a similar widget for the slice. So I will say, this time I don't want to slice in this direction. I want to slice in the Y direction, like that, because I want to see, of course, the data. And then I will press apply and hide the plane. So now we have some kind of slice here that we can see.
Okay, I've seen that there is also a contour filter. Can you highlight how this would work on these datasets?
Sure. So if we want to do the contour filter, we want to do it on the volume, right? Not on the slice. That's for sure. So let's select the clip and add the contour filter on the clip to be able to create a contour on the volumic data. So we just press selected the clip and then press contour. As you can see, when the contour, I need to select with which parameter to do the contour with. So this is fine. And press apply. The right values.
Maybe we can try a range of value.
Yeah, that sounds good. On the right.
Maybe that's not the right scale.
Yeah. Yeah, that's
better.
Much better. So now I have a contour. Of course, this contour is taking a lot of we cannot see it through. So I will add some opacity on it. Oh yeah, now we can see it. And also we don't need the big volume anymore because it's a bit confusing now. So I will just hide the clip.
Yeah. So it seems you made the contour using another value that's the one which is shown on the screen.
Yeah.
How can I switch between the displayed value on the screen, the colors for the models?
So let's say I want to on the moto, I want to show the value I use for the clip. So I will just select the moto, and or maybe do that on the slice. It will be better. So I will show the slice again. So we have our slice, and I will change the representation on the slice. So here I can see that the slice is colored using the p-value. So I will just change that to another value, and I will switch to omega.
Nice.
Or maybe not. Yeah.
I see. And when working with this kind of CFD data, maybe we can also be interested with some glyphs or streamlines. Can you give us an example of this kind of processing?
Sure. So let's start with streamlines. So for the streamlines, you want to do the streamlines on the volume. You have to put some seeds into it, and the streamlines will just compute the movement of the particles. So to do that, let's select our clip volume again. I will hide everything and add a streamlines. So streamlines is this one, stream tracer. And as you can see, it suggests me to use this line source here for the seeds. We will not use that, we'll just use a point source. So instead of using seed type line, I will use seed type point cloud. As you can see here, it suggests me this location, which is perfectly fine. And then we can see the vector is using u is the velocity, so that's what we want. And I will just press apply. Okay, now I have some streamlines. I will hide the sphere, we don't need it anymore. And maybe color the streams with another data. For example, the velocity. And I will hide the clip like that.
Oh, this is looking great. What about saving this as an image for an article, for example? How can I do that?
So basically, you want to use a save screenshot feature. That's very easy to use. You just go into File, Save Screenshots. Okay, that. Then you just select a location for your screenshot. That. Okay, and it will ask you some questions. The resolution of the image. If you want to change the color palette, well, for now you don't need to change anything, and just press OK. And like that, my screenshot has been generated.
Okay, and is there a way I could share my workstation with a colleague by saving some, I don't know, some script or state file?
So there is a concept of state files that will let you share the state of the application into a file that can be opened by your colleague or by yourself later down the road inside ParaView. So how to do that is using file save state. That, and just select a location on your disk and press OK. It will save the state. But let's check it worked, right?
Mm-hmm.
So first I will reset my ParaView from scratch, and for that you want to use edit reset session that lets you remove everything. Edit reset session, it was means that it will remove everything, and I'm from scratch, and now I can load the states. So file load state this time, and I will select this file. When I select it, it will ask me the location of the files, because the state file will not save the data. It will only save the how ParaView is set up. The data is must be provided by the user. So when you load the state file on your own computer, of course the file have not moved around, so it will work. But if you share the file and the data with a colleague, maybe the data will not be at the same exact location. Then you want to use this. For example, if you choose file names, it will tells you where are the file located, and you can change that. And you can also search all the files in a specified directory. This way it's a bit more easy when you put all the data in specific file. So I will press, I don't need that for now, so I will just press OK. It's loading everything, computing everything it needs to compute, and we are back where we are.
Nice. And if I want to save the result of my processing, like saving some specific output as datasets.
Sure. So let's say you want to save the streamlines, and so the streams itself can be reloaded into another software, for example, for nicer rendering or something you want to do something different with your streamlines. So first you need to make sure you select your active source is selected. So you click on it, and you go File, Save Data, and then you can select an output format. That, and I will just save my streams here. It will ask you some questions. To be honest, you don't need to change much. Just press OK. And let's say we want to check this has worked. So I will reset my session again and open the file. So I have my streams.vtp, and I can open it. Only the streams.
Oh.
I also want to mention that ParaView supports many file formats. So yeah, in more generally, most files can be opened. If your file format is not supported, there is always a solution, like creating your own plugins or programmable source, this kind of thing. So do not hesitate to try to open your files in ParaView. And if you have any questions, you can just ask us. We can help you find out the right way to open your files.
Just one other thing before we take the question from the chat. We have seen that we can reset the whole session, but can I also remove just one filter or one step?
Good point. I should have shown that. There is this delete button. It's a bit obvious to be honest. You just press delete and it will delete the source.
Okay, perfect. We also have one question from the chat, which we asked to demonstrate some experimental data visualization. I don't know if we will have the whole time here, but things like Lagrangian trajectories. And the question is about what kind of post-processing can be done for providing flow field and calculating vorticities in ParaView.
It's a bit an advanced question. It's a bit out of the scope of this webinar, I'm afraid. But so what you want to, Alex, what you want to take a look into is first try to use the stream tracer. The stream tracer does compute the vorticity, so maybe that's enough for you. And if not, you may want to take a look into the Lagrangian particle tracker. So search for on Google for Lagrangian particle tracker. It's a plugin which is in ParaView. You can load it and use it. It's much more complex to use, but you can do anything you want with it. So you should take a look. I think there is another question.
Can you show displaying vectors like glyphs? We mentioned it, but we didn't.
Yeah, let's do that. I think there is another question you missed.
Yes.
Let's start with the glyph. So,
network error.
But it's still working here.
Okay.
So I created the glyph, and I know I can choose. Now I can choose the orientation array of the glyphs. So the velocity is fine, and I can choose a scale array. So I will just don't choose any scale array and press apply. That's maybe of course the velocity, the direction is a bit straightforward. But let's let's try to use a scalar array to show something. So with omega, and we will. That's not yeah, maybe this is. So here we have the glyphs which
stream is offline.
I hope you can hear us well. Looks like we have some. Yeah, you missed the glyph explanation. Okay, let's start it again. Okay, so we are back to business. So let's add some glyphs on the motor. So I will select the motor.vtp and press the glyph button here. So I have glyph type is arrow. So yeah, that's fine. The orientation array is u, so that's the velocity, and a scale array is p. So I'm using data to scale the arrows. I will just press apply, and yeah, that's not the right value. Something like that. Yeah, so it's moving around the orientation because the scale array is actually negative here, so that's why it's going this way. And we can see we can see the pressure on the different element with the velocity at the same time using the glyphs.
And in terms of scalar value, I mean, in color on the screen, can I show some vector?
What do you mean? Sorry.
If I want to have a vectorial data shown on the screen, for example, if I want to show you as a color array for my data,
sure.
What can I do with that?
You can just well, U is not great for the glyphs because U is uniform here. But let's show U on the slice, something like that. Here you can show U like that. Let's hide the plane, and when you show a vector, you can select the component if you want. Like that.
And there is a question I missed at first, so we'll come back on it. Is it possible to visualize geotiffs in ParaView as well?
So I'm not entirely sure of the format. So is that yeah, I'm not entirely sure. Let's check here, but I don't see any. We support TIFF image, that's for sure. But GeoTIFF, I'm not entirely sure. I would have to check. Yeah.
There is a question about if we can share the presentation because of the small networks problem we had.
Well, to be honest, the presentation is very short, but the video will be online after the webinar, after the live. So you will be able to look at it again, and there should not even be the missing part.
Okay, and I think we have the time for one last question. So is it possible to create reference geometrics like cylinders or cubes and then use that as a control volume to do volume integration, such as pressure or velocity fields? I'm not exactly.
Yeah, I don't get it.
I'm not exactly sure about the question.
Is it possible to create reference geometry and then use that as a control volume to do
so
the
integrate along a surface or along a geometry?
Yeah, you can integrate along a line. But yeah, I'm sorry, Ryan. Maybe you want to ask this question on our discourse, and this is what I wanted to talk about just after that. So that's a good segue. So if you have questions we cannot answer today, and if you have any generic question about ParaView, even perfectly beginners questions, you want to go to our discourse to ask questions. So the discourse can be found here. Just look for ParaView discourse on Google. And here you can ask any questions you want about ParaView. Generally, you go to ParaView support and you just ask the question. As you can see, there is many questions, many people interacting with the community. So we will be very happy to answer you. People from Kitware, people not from Kitware, anyone can interact there.
Okay, thank you, Mathieu, for this nice presentation. I think we have a lot of things to try at home with all that you showed us.
Yeah.
So thank you again, and I don't know if you have anything to add.
Well, that was a pleasure. Thank you, Charles, for interacting with me today. That was great, and thank you everyone for connecting to this webinar. We hope to do more webinars in the future. The subject is not fixed yet, so if you're interested by that, just keep an eye on our LinkedIn for new information about next webinar. Yeah, that's it.
Thank you.
Thank you, everyone. Bye.